You should have in VS Code in the Explorer sidebar. You should have chapter 15 class notes is what is open, not the data structures project, because we need to be inside of this folder for the Java stuff to work. And if you click on lessdemo.java and open that up, this is the file that we're going to be coding in together. So my purpose here is I want to show you most of the methods, but not all of the methods that you're responsible for. Again, the complete list of methods you have to know are in those slides. Every method that shows up in those slides, you have to know without the aid of a quick reference. So let's see some examples of how we operate with a linked list. So inside of our list demo class, inside of the main method, often I add like a comment. Let me undo that to provide some context, and then we write a little bit of code. In VS Code, if you type /star, it automatically completes another slash and star. And then if you hit enter, it will build up a comment block for you, which is like super nice. Okay. So the first method we're going to explore is the add last method. So I'm going to say the add last method can be used to populate a list. So we need to build up a list before we can start trying all of these methods. And actually, before we can start calling the add last method, we need to make a new linked list. So let's do that first. So I'm going to declare a variable of type linked list, and we're going to have a linked list of strings. And this is going to be like a list of like staff at a company or something. So I'll call my variable staff, and then I'll say new linked list. Now, what you'll notice in VS Code is as you're typing things, IntelliSense is like code completion. It's going to make some suggestions. So I type the letter L, and it says, well, maybe you want to make a new one of these. But it's smart. It knows I'm assigning this reference to the staff variable, and it knows the staff variable is of type linked list. So the first recommendation is you probably want to make a new linked list, and it's right. So I can keep typing if I want, or I can click with my mouse, or I can just hit tab, which is what I usually do. And then I can take advantage of the code completion. So IntelliSense code completion is like super nice. You'll also notice, and this is something that we'll do a lot of, you're used to generics from an array list, right? Like you have an array list of strings, an array list of turtles, an array list of capital I integers. Same thing here, linked list of strings. Because the type of the variable staff is explicit that this is a linked list of strings, we do not have to put string here. We can, and that will compile, but it's redundant because it's implied by the variable we're assigning it to. So we can make this a little bit more concise by, we still need to specify that linked list is a generic. We still need the opening and closing angle brackets, but we don't need to put the type in there, okay? So you'll see me model this where I don't put the type here because it's specified here. And that's something, honestly, we didn't worry about in AP Computer Science A because y'all didn't need one more confusing thing to deal with. So, but now you've got that figured out. So now we'll add more things to deal with. All right, let's use this add last method. So I'm going to type staff. And even as I start typing staff, you'll see that IntelliSense recommends that I hit tab and complete that. When I type the dot, IntelliSense will show me all of the methods I can invoke on a variable that refers to a linked list object. Okay. And I could find the one I want. I can scroll through this list if I want. That seems like a lot of work. So usually I just start typing to narrow it down. Like I know I want add last. So this helps. It narrows it down. I can use the arrow keys if I don't want to touch my mouse. And I can go down to add last and hit enter. And it types add last. It adds the parentheses. It puts in a placeholder for the variable. I'm going to replace that with Diana. If I hover with my cursor over add last, I get inline documentation from IntelliSense, which is wonderful. It has here the method like header. I can see the return type is void. I can see it takes one parameter of type string. I get a brief description of how it works. I can see all the parameters listed. Super, super nice. The other thing you'll notice that's unique about VS Code, and this can cause some confusion at first, the variables are annotated. If you notice, in front of Diana in light gray, there's an E colon. If there were multiple variables, each of them would be annotated with the name of the, I'm sorry, multiple parameters. Each would be annotated with the name of the parameter, the colon, and then my value. When you're typing code and we're doing live coding, you don't type E colon, right? Like that's not Java syntax, right? The light gray stuff is like automatically put there by IntelliSense. We're not typing it. So all you've typed on this line is staff dot add last, open parenthesis, double quote, Diana, close, double quote, close parenthesis, semicolon. That's it. You don't type the E thing. That won't compile. Just like you never did that last year. But that's new. BlueJ doesn't do that. But it's really helpful when we have methods that take a lot of arguments and we can just at a glance know which one is which, because I get confused. You probably don't have this here, like this other light gray thing. This is for a VS Code extension that I like that helps me with some GitHub stuff. So you can just ignore that as well. Maybe I should turn that off while we're doing this. All right, let's add some more things to our list. Again, we're going to stick with the British royal family and Shakespeare characters because that's what's in the book. So this all models like what you read. So let's do staff.addLast. And let's add Harry after Diana. And then we'll do another add last. And after Harry, we'll do Romeo. And you can type add last and like now capitalize the L, but then when you hit tab, it will fix it for you. That's also nice. We'll put Tom after Romeo. I don't know if Tom is a British royal or a Shakespeare character, but we're going to throw him in here too. I'm going to add a comment to like capture what the current state of our linked list is. So I'm going to say the list is currently, and I'm just going to use their initials, Diana, Harry, Romeo, Tom. That way, as we call different methods, we can keep track of what the list looks like. All right, we're going to explore list iterators. That's the new concept for today. So I'm going to start another comment block, /start enter, and I'm going to describe conceptually what a list iterator is and explain how we'll like capture it in comments. So the list iterator method creates a new list iterator that is positioned at the front of the list. So that's an important thing that I didn't share before. When we make a new list iterator, it starts at the front of the list. I think that makes sense. In our comments, we're going to use the vertical pipe cat character, which is above your enter return key. We're going to use that in the comment. So the pipe in the comment represents the iterator position. So I'll show you what I mean by that. All right, let's make a new list iterator. So we're going to say list iterator, second choice, not so bad. The list iterator is also a generic because when we call next or previous, it returns a reference to an element of the element type. So this needs to be a list iterator of strings. I'm just going to call it iterator. And then I'm going to assign it to staff dot. And I love this. So because I've already written, because I'm assigning the return value of the method I'm about to call to the variable iterator, IntelliSense is smart enough to realize like, oh, you probably want to call the list iterator method. So it's the first one on the list, and I can just hit tab. I'm going to add a little comment here to say the iterator is at the beginning of the list. So I'm using the vertical pipe character, and then we have Diana, Harry, Romeo, Tom. That's what things look like right now. All right, let's try this out. So /star enter. The next method also returns the next method advances the iterator over the next element in the list. All right. We saw that on the slide, but now we can see it in the code. So if I say iterator dot next, that means I've gone over Diana. So now my links list is Diana. The iterator position is between Diana and Harry, and then we have Romeo and Tom. Questions about the syntax I'm using in the comment to represent the elements of the list in the iterator? It's like important we're on the same page with that. That's a key thing as we're writing the code. Let's see what else the iterator method does. So the next method also returns a reference to the element that the iterator is passing. I think of it as like we're passing over an element when we call next. So if I create a local variable of type string called name, I can say iterator dot next, and then we'll capture that. That means we have Diana. So I just passed over Harry. The iterator is now between Harry and Romeo, and Tom is at the end. So now if I print this, system.out.println, so it's like, guess what? You probably want to call println. So I just hit tab, filled it all in. I want to print name, which is the name, which we expect to be. So we'll print this too. System.out.println. We expect it to be expected Harry. Often when we do live coding, and often when you do pair programming or individual programming, that I'll give you like test code. Like you don't have to write the test code. I'll give you the test code. It's not like formal like Java unit tests usually. Sometimes it is. But it's usually like we print something and then we print what we expected. So when we run the program, we can look at it and actually see what it looks like and if it looks correct. So, all right. So there's next returning a value, which we've captured in a variable and we've printed out. All right, let's try another common method. Again, we're not going to hit every method in the slides, but we're going to hit a representative sample, and then you can make the connections. Like if you understand next, you can figure out previous, for example. We'll still do some previous stuff, but all right, let's do the add method. The add method inserts an element at the iterator position. One thing I glossed over, which is really important, is okay, I understand where the new element is added, but where is the iterator after I add that new element? That's like super important to understand. So the iterator is then positioned after the element that was added. And we're going to see this with this example here. I want to emphasize this because in my humble opinion, or maybe not so humble opinion, the text is a bit confusing on this point. Okay, so just a warning. I think Kai Horseman writes an incredible textbook. The guy is great. Best Java textbook I've ever seen. And there are areas for improvement. Yeah, Brendan. Yes. Take the passive if you would. It's right by the to the right of the door. All right, so let's see what this looks like. Let's do iterator.add, and let's add Juliet to our list. Juliet. All right, so our iterator was between Harry and Romeo, so that's where Juliet is going to be inserted. So we'll have D, H, Juliet goes right here. The iterator is positioned after the element that was added. So the iterator is here. And then we have Romeo and Tom. That's the current state of our list. Let's call add again. So we can call add over and over again. Totally fine. Let's add Nina. So the condition is we have to call next before we call add. That doesn't mean we have to call next immediately before we call add. We called next up here, and then we can call add over and over again. That's okay. So we're going to have Diana, Harry, Juliet. The iterator was between Juliet and Romeo. So Nina goes in here. The iterator is after the element that was added. And then we have Romeo and Tom. Let's dive into remove. The remove method removes the element returned by the last call to next or previous. Okay. We had the same information on the slide. This is different than add. Okay. So the remove method can only be called once, exactly once, after calling next or previous. Okay. With add, we could call add, we can call add as many times as we want. With remove, we have to call next or previous, and then we can call remove, but we can only call it once. So we can't remove two things in a row. Okay. So the remove method, we can't call it two things in a row. We can't call it after add either. The remove method cannot be called after calling add. It is, you might be thinking, and it's quite reasonable to think, this seems like a lot of rules. Who made up all these rules? Why are they making my life so hard? I agree with you. Next chapter, when we write our own linked list class and we have to implement the remove method, at that moment, you'll be like, oh, I get it. Now I understand why remove has all these restrictions because I'm actually implementing the remove method and I understand why. So just kind of go with it for now. And when we get to chapter 16, you'll be like, okay, they're not just being mean. There's a good reason for these rules. Yes, there is. That's a great question. We get the illegal state exception. I couldn't remember what it's called. But yes, if we call remove twice, we're going to get an illegal state exception. All right, so let's call iterator.next first because we have to. We just called add. If we were to call remove, that would be a problem. And so if we call next, we're going to have Diana, Harry, Juliet, Nina, Romeo, iterator, Tom. So we just iterated over Romeo. So if we say iterator.remove, what element gets removed? Romeo. Wherefore art thou Romeo? You're gone. You're removed. Diana, Harry, Juliet, Nina, iterator, Tom. Romeo is gone. One thing that was cool about array lists is we could just pass a variable to system out print line and it just nicely prints the whole array list. That's not anything special about array lists. That's true of all collections. So we can do that with our linked list. So we can do system.out.println and we can just pass staff. And then I'm also going to do another expected. I'm going to type out their names. You might want to just like type their initials just to save some typing on your part. I really like to type, but all right. So we've done next, we've done add, we've done remove. Let's just do previous because I want to do a previous with a set so you can see like what that looks like. So the set method updates the element, changes the value of the element. It doesn't add or remove anything. Updates the element, return by the last call to next or previous. So if I do iterator.previous, we'll have Diana, Harry, Juliet. The iterator was right here between Nina and Tom. I called previous, so we're going the other direction. So we just passed over Nina, and now the iterator is between Juliet and Nina. So therefore, if I say iterator.set Albert, Diana, Harry, Juliet, we just iterated over Nina with the previous call. So Nina is changed to Albert, and the iterator position does not move. All right, so we did next, previous, add, remove, set. We created the list iterator. We hit most of the list iterator methods. Tomorrow we'll explore like has next, has previous type stuff. But this is a really good point to pause. Let's run this code and see if it works. Here's how you run Java programs in Visual Studio code. So if you scroll back up to our main method, you'll notice there's this little like link that's between lines 9 and 10 that says run and debug. If you click on run, it will automatically do all the things to compile your Java code and run your Java code. It opens up a terminal. You can see like it printed Harry. We expected Harry. It printed Diana, Harry, Juliet, Nina, Tom, and it expected Diana, Harry, Juliet, Nina, Tom. This looks really good. If this doesn't work for you, I'll help you in just a second. Okay. What I want to show you though is if you click on, before we run out of time here, if you click on the third button in your toolbar, it looks like a Git. This is meant to be like a Git branch. You should see a little one here because we've changed one file. If you click on that, it brings up the source control sidebar. Up here where it says message, you can type like what we did today. So I'm going to say like add notes on list iterators. We'll talk more about commit messages later. If I hit commit, It commits my change, which should be familiar from using like BlueJ or GitHub Desktop. But then I also want to click this button. This is the sync button. This is going to push it to GitHub. If I don't hit the sync button, the code is only committed on my classroom desktop, and it's not yet on the GitHub website.